Hello, I'm Angelina, and welcome back to another episode of our interviews. As always, feel free to open up the transcript or the description to better follow along and learn more about our guest speakers. Um,
Hi,
okay,
hello.
hello. How are you doing today?
Uh, Hi, Angelina.
Oh, hello, Narayan. So if you don't mind, can you walk us through your journey, sort of like how you got here, where you went to school, and like what you're doing right now?
Oh, yeah, sure. First of all, thank you, Angelina, for inviting me to this podcast. And so giving a brief introduction about me, I'm doing my undergraduate studies in theoretical and mathematical physics. And yeah, my particular area of interest is basically studying about the underlying mathematical structures of theoretical physics theories. And from the past few months, I've been trying to incorporate artificial intelligence and machine learning into my research. And yeah, I'm also doing research in the fundamental mathematics underlying the artificial intelligence also. So yeah, that's a brief introduction about me.
Thank you so much for the information. Was there anything that like sort of got you
Yeah,
doing math or like
yeah. I was just going to say that, yeah, from early itself, math had interest. I had so much interest in doing maths and what we say. I was so basically studying physics, degree, but my main area of interest is, I would say, studying the mathematical structures behind these physics theories. That I wanted to add that part.
wait, you said that you were very interested in math. Were you always like, did you always know you were very interested in math, or was this something that like developed over time?
First of all, I wanted to say that basically both of my parents are researchers. My father's a mathematician by himself, and he works in number theory. And my mother's a theoretical and computational chemist. So from early childhood itself, I was so much interested in mathematics and doing mathematical problems, Olympiad problems, etc. So I knew I had interest surrounding these areas of physics, maths, and computer science, all these somewhat mixture. I knew that I had a brief interest in these areas. And actually, when I grew older and when I was in sixth standard, actually that's when I was I got more into deep maths. Actually, I joined of the Olympiad training camps. It is known as Intelligent Planning Forum in our city. That is like the top training camps in our city. So somehow I had got the opportunity to attend that camp, and there was like so much great teachers out there who just taught wonderful maths. And then yeah, from there I picked up interest, and yeah, it grew a long time. And when I was in high school, I started solving more deep level, like level maths. And in my high school, actually in India, what happens is you have to give an entrance exam for getting admission to top university. So it was termed as AEE, joint entrance exam, and I had a decently good rank in the examination. I was able to get into this institute. It is one of the top institute for science and engineering in India. And one more thing I want to uh, uh, put out is that in both 10th standard and high school, I was actually the topper in mathematics in my math subject in my entire school. I was a school topper, so that was actually I'm proud of that. I scored the highest percentage among all the students in my school in high school and in 10th standard actually. So yeah, and entered my college. Actually, I grew large. Actually, I was in a dilemma to choose like which one, actually maths or like physics. Then I thought I will go along with theoretical physics so that I could learn maths and theoretical physics hand by hand. And yeah, I started my journey in mathematical physics and underlying mathematics and geometry behind all the theories. And basically, we study in theoretical physics.
Oh, thank you. It seems like you had a pretty successful like academic story. Do you have any like tips when it comes to being successful academically? Like you said, you scored really high on the exam and you're in like one of the top universities in India.
Yeah, I would like to say that what I used to do when one thing I always thought is that it is not like proper to study like focusing on like entirely on the exam. Actually, you have to have a broad idea, I would say. One thing I will definitely put out is that like you have to have a broad idea, even like apart from what is actually in the syllabus. I would like to say to everyone that like you have to it will be very good if you have a broader idea out of syllabus things also if you have covered. It will give you a very good idea and very good base for studying higher level maths. And one more thing I would like to put out is that solve as much problems as possible, because I still remember when I was in like seventh standard, eighth standard and all, I was solving like almost hundreds of problems a day. Like I used to just sit and like solve all the problems. We just used to get mock papers in our school, so like I used to solve them from like I used to sit and solve them and also I used to keep a track of how much time I am taking to solve each problem so that I can increase my speed. I can just evaluate myself how much and with what pace I'm able to solve the problems. These two are, I think, basically like what you need to excel in exams.
Okay, thank you. I think on your LinkedIn page, you also mentioned that you believe that mathematics is the language through which God has written the universe. Is there a particular experience or like something you'd like to share that has like sort of allowed you to have this belief?
Yeah. Like, first of all, I see all the theories which have been formulated. If you take from engineering science or like physical science, natural science, like even in chemistry, and I can even confidently say, even if you take some of the theories in biology, life sciences, you can see that most of them are formulated from basic pure maths principles, actually. Even if you say some of the latest trends in computer science or in artificial intelligence, you can see that like when it was first formulated, they were primarily formulated using the basic ideas of pure mathematics, such as linear algebra, differential equations, etc. And from there, it grew apart. And like all the upcoming, what we say, research topics in these areas are basically strongly depend on the higher level mathematics, research level mathematics. And also you can see all the applications in daily life we do related to engineering science and other science, etc. They are basically formulated or like put out in the form of differential equations. We know differential equations and calculus in the form of calculus and differential equations. So anything if you want to go into deeper and study what exactly it depicts, obviously it is only possible in the form of max. Without max, obviously we can't study anything deeply, and we can't also what we say we can even say with max we can even predict what the system is trying to convey to us, etc. So I feel like whatever we see around is like basically max itself, and max formulated with certain other theories and conjectures, etc. That is what I believe, and that's why I had written in my LinkedIn account that mathematics is the language in which God has written the universe. Yeah.
Yeah,
Yeah, sure. And no, actually, I was going to say, even one of the great physicists, Albert Einstein, and one of the great mathematician, Srinivasa Ramanujan, they also had the same idea. They were saying that, yeah, it is like everything you see around is max. It's just you just formulate one theory, and when you put your pen down to write it in a paper, it's just max. Like they also had the same idea, and I'm strongly, what we say, motivated by these two people. So. Yeah.
is there anything you've done like research wise or like studies wise that you're extremely like proud of and would like to share?
Yeah. So as I said, basically my area of interest is studying the mathematical structures underlying the theories that we come up in theoretical physics. So in theoretical physics, mainly the theories I'm interested in is gravity theory, or in a general way, we call it as general relativity, and also quantum field theory. So these two theories, I'm interested in the mathematical and geometrical principles underlying these theories. So recently, I have been working on one of the research papers It's not completed, but I'm still working. What is basically is on like understanding. There is some one concept known as semi-conformally flat spacetimes. So there is one modified gravity theory known as FRLM gravity. So what I was studying is what are the properties of the semi-conformally flat spacetimes in this particular obeying this particular gravity theory, FRLM gravity. So I was able to come up with almost, I guess, 7 theorems, and now I am drafting the paper for that. And apart from that, I have already published 2 research papers as an undergraduate. One entirely based on space-time geometry, which actually says that there is a space-time known as Einstein space-time. It is topological and it studies certain other properties with respect to the incompleteness. And one more research paper I had published earlier. It was basically on artificial intelligence. And what actually the paper was doing is it was able to predict that artificial intelligence, so the machine learning model that I created, it was able to predict the corrosion inhibition of certain materials when we apply it to metals. It was actually collaborated with my twin brother and my mother. So it was like a mixture of maths, artificial intelligence, and chemistry. And I was able to come up with a really good paper, and it was published in a really high impact factor journal. And my second paper was also published really nice about modified gravity theory. And recently, I have been trying to use artificial intelligence and especially machine learning and neural networks a lot to study mathematical principles. Like actually, you can directly prove or generate theorems or conjectures with the help of artificial intelligence. Using a special type of machine learning or artificial intelligence architecture known as physics-informed neural networks. So I'm basically doing research in that physics-informed neural networks. So yeah, hopefully I'll be publishing the paper within like 2 months or 2.5 months. Yeah.
And then I've noticed that you've done like a lot in a lot of different fields, like quantum computing, like relativity, physics, and math. Do you find that like all of these are like sort of related? And like if so, like how exactly are they related?
Yeah, first of all, I want to emphasize the fact that whatever we see the research now going on, like in trending way, it's like completely interdisciplinary. Like in the least, we can say that like these 3 fields, physics, mathematics, and computer science, more specifically theoretical computer science, these are like interrelated very strongly, that each field is helping other field to develop new research works. So actually it was like this, like earlier maths helped artificial intelligence field a lot to develop, and now you can say that this AI field or machine learning field is giving back to maths actually. And this concept of quantum actually earlier we had this classical information theory or classical computing, and now which is getting very popular is that quantum computing and quantum information theory. And also which is very highly trending is that quantum machine learning. So we are like it is being said that what the classical computing systems are able to do in a large amount of time, this quantum computers can do in a very short while, so that like it will make our life easy, like very much easy and faster. So yeah, I feel using this quantum machine learning as well as this normal classical machine learning and artificial intelligence in maths is a very good idea, because actually one more very interesting artificial intelligence architecture came up like I guess 1 month back. It was done by Northeastern University in USA actually. Some researchers in Northeastern University, they actually drafted a paper and they created an entirely new AI architecture which were able to solve the problems in complicated physics theories very fastly and efficiently. So yeah, and actually that was formulated using basic principles of multivariable calculus. and linear algebra from max. So you can see how the networking goes. Using max, you develop artificial intelligence, and using artificial intelligence, you can again study physics theories and mathematical theories and conjectures, etc. So I think it's like this. It develops like new research works come up, and yeah, and this physics principles are also being used to get generate new conjectures and axioms in mathematics also. So it's like interconnected a lot. And quantum machine learning, quantum computing, etc., is like now being used a lot to generate mathematical principles, mathematical conjectures, solve physics theories, get deep insights into like quantum mechanics, quantum information, etc., etc. This quantum machine learning is being now used a lot. So I would say this entire thing is like interconnected, and if you want to get a very good grip of what is going on behind, so I feel you will have to. It will be very good if you can get a whole picture of all the fields, so that you can like interrelate everything and develop everything much more faster. And yeah, obviously develop everything.
So like on this idea of like there's sort of like this loop where like math and physics improves like machine learning, which then improves like math and physics. How far do you think like
Yeah.
machine learning, math and physics can like advance within the next few years?
Okay. From okay, I can say that this machine learning is now being used like a lot. It's like going beyond what like we are even thinking. There are very new fields known as computer vision and all. This computer vision, what they do is they can do image classification also. Like I'm personally I'm of the project. What the project is doing is there is in max there are some structures in a particular topic known as Lie algebra, known as Dinkin diagrams. And so what this computer vision can do is they can classify the images using machine learning architectures. So so what I can say is actually in artificial intelligence there are like many fields coming, and there is a very new field known as natural language processing, which can actually recognize our speech. Like if a particular person is speaking, it can recognize the voice and give certain predictions and output. So it's like developing day by day actually, and people are working a lot in this. And I hope like very recently machine learning model was created, which was actually able to solve math Olympiad problems with a very high accuracy. So you can see that actually machine learning and artificial intelligence models are like even able to do that. So I feel like it's going in a very fast pace, and maths research I would say is also going in a very fast pace. But the thing is, lot have been done in classical mathematical theories, like in number theory or like algebraic geometry, and a lot have been done. So what I have personally felt is that to go ahead more, it takes time. And if you are working in pure maths, it will take time to get into new conjectures or new theorems. But when you go into a field of applied maths, it is getting what we say developed much fastly. But in pure maths or like classical mathematical theories, it is taking time to generate new ideas and new research. And talking about theoretical physics, it has always been like such a field that it is developing, and it is also developing other fields. It is getting developed and it is also developing other fields. So like as I said, string theory and quantum field theory, they are giving new insights to like even machine learning structures, and new insights into mathematical principles also. So I feel now we are dealing with the latest research works is on quantum computing, and I feel something related to string theory will be coming up in like next like 20 to 30 years, and we will be able to predict much larger things and go deep inside. Yeah.
That's so cool. Thank you for telling me about all of this. I like never heard of like this sort of loop thing. Like that's really cool. Oh, okay. Is there any like last things you'd like to share or anything?
Ah, yeah, like one thing I want to share is that for those Gen Z and Gen Alpha students who are interested to do research in this field of theoretical physics or mathematical physics, artificial intelligence, etc. I would like to say to them is that keep your passion high and work hard. And obviously, I want to suggest something to high school students, especially. Actually, when I was in high school, I actually read a lot of amount of books actually. But I want to give an advice to the high school students that like you can read the books, but along with that, actually they can go ahead and read research papers available also, so that they can get really new ideas and new concepts from very age itself. So who knows, they to publish a lot new researches. So one thing, that is the thing I will like to give advice to all the youngsters, or the try to read as much research papers as possible. Try to solve the problems, I would say research level problems, so that like you can come up with new ideas and like even publish it in a journal and make a mark in the field actually. That is one thing. And other than that, yeah, do hard work and keep your passion high. And for I would say there was a like not reluctance, there was like some this thing regarding I would say the participation of like girl students in this mathematics fields were less, but now I would say yeah, there is considerably a huge amount of female participation in mathematics. Actually, one of the recent Fields Medal was won by a female mathematician. Earlier, it was not the case. So actually, the trend is changing actually. So I think, yeah, that's the thing I want to conclude by saying, yeah, you do hard work and study what you love, and make the most of it.
Okay, thank you so much for taking your time and being here and sharing all of this amazing stuff with us.
Yeah,
Thank
thank
you.
you, thank you, thanks a lot.